And I'm kicking it to Al and Dick.
Okay, guys, we're here today, tomorrow, and Thursday to talk about DSOs and how they can be integrated into the classroom to enhance student learning. I will be doing today and a little bit of tomorrow, and then the master will come in and do some hands-on work. It's our understanding and belief that there are some instructors out there who are power scope users and do a great job with scope use and instruction, but there's also a population that either isn't comfortable with scopes or don't believe that they're necessary at either the high school or college level or even as a technician. We want to change your mind if that's you, and this brief PowerPoint today is part of a large one that we're going to share with you that brings someone who doesn't know anything about scopes up to a certain level of competence. And then if you are already a power scope user, you can use this tool to teach with to your students. So because of that, there is a PowerPoint available for you. It covers why use a scope, comparison of it to a digital multimeter, sample patterns, basics of use, advantages of using, and test procedures. Right now, there's 170 plus slides, which is typical of a Krieger PowerPoint. And I will be happy to share that with you. And all you need to do is send me an email like you did with the relay PowerPoint. So either in the, preferably an email to my Council Lab account, I will share with you that PowerPoint using probably OneDrive. It also includes the class handout that we use for our two classes, Intro to the DSO and using the DSO in the classroom. So because we're going to go fast today, I want you to hang on. The advantage is we're going to go fast. That's a disadvantage. The advantage is you're going to get a copy of this PowerPoint that I'm using today for your use. So if you forgot something or didn't quite catch it, you will have a copy of it. We all know that hands-on learning is the best way of students learning. And so should I be teaching scopes to my students? And if so, what is the best and most cost-effective way to accomplish this? Scopes allow students to see what's going on in a circuit. We find that as a distinct advantage as opposed to reading it in a book or seeing just a meter reading. Scopes provide a better method of teaching circuit characteristics. And scopes are now considered an essential tool for today's technicians in most aggressive shops. Krieger, I've got a multimeter and a scan tool. I seem to do pretty well. Do I really need to use a DSO? Tell me why I should learn and teach DSOs. DSOs allow signals to be seen in great detail. They measure signals very fast. Nothing is faster. They can record signals for later analysis and comparison. The only tool that can catch and identify intermittent glitches. Results in student engagement. Transducers can be used to measure pressure, vacuum, noise, and so forth. Students learn more effectively by seeing the circuit in operation. It's the only tool that can quickly and accurately diagnose CAN bus systems. DSOs allow you to conduct relative and actual engine compression testing in a fraction of the time compared with using a compression gauge. It also can be used to determine valve seat operation, valve sealing, flat cam lobes, cam timing, the whole 9 yards. Current ramping is used for electric motors, injectors, and coils for very accurate diagnosis. It allows viewing of multiple signals, volts, amps, pressure, vacuum, and so forth at the same time for comparative purposes. Rapidly becoming an essential diagnostic tool, and many shops are now routinely using the DSO. You provide better trained students if they already have a basic competency level of the scope. What is a scope? Most of us know that it's nothing more than a visual voltmeter displayed over time. No matter what kind of scope it is, all it can do is measure voltage. So if we have a straight line, no voltage, we're going to see a flat line on the scope. In this case, we go from off to on, stays on, goes off, stays off, goes on, stays on, goes off, stays off. We now recognize that as a digital on-off signal, and that signal is displayed over a certain amount of time. We choose that time when we set our scope up. Those are digital signals, which means they are either on or off. Or we can have analog signals, which means they can vary. Oscilloscopes aren't new. It was invented in 1897. The analog scope, which is what used to be most accurate, they still are accurate and used in many electronics labs. There's no averaging, but you cannot record for playback evaluation. The digital storage oscilloscope, DSO, is different, and it can restore or store patterns. There's a bench type unit. There's handheld units. That's the old Fluke 97 that many of you may be familiar with. And there's the UScope. And the storage is the key advantage here. We can store signals and go back and look at them. They can be PC or tablet based. They can be integrated with a scan tool. A scope has channels, which is how many voltmeters it contains within the unit. A one-channel scope, two-channel scopes, three-channel scopes, four-channel scopes, and now we have 8-channel scopes and some even more than that. How many do you need? Well, for teaching purposes, I think you only need a one-channel scope. For work on cars and comparative signals, especially with CAN bus, you need two channels. You need 4? Probably not. But as you get into the shop and start repairing cars, maybe. Each of you will have your own opinion on how many channels you need. Along with the scope, you need accessories. A scope will have either banana plugs on it or a BNC connector. So now you begin to fill your toolbox up with probes, needle probes, wire piercing probes, alligator clips, ignition harnesses, COP paddles, which is one of the main advantages of a scope. And if you already have some of these things, especially some of the amp clamps we'll talk about in a minute, you can get adapters to go from BNC to banana or banana to BNC. Amp clamps, one of the primary advantages of a scope is to see current ramping of fuel injectors and fuel pumps and ignition coils. Any amp clamp that you have right now that you use with your voltmeter can be used with a scope. They're no different. Pressure and vacuum transducer kits. These will allow you to do in-cylinder compression testing, vacuum, back pressure testing of the exhaust system, fuel pressure, you name it. And the nice thing about a pressure transducer in the cylinder is you can see the actual 4-stroke cycle. This is a pattern of a scope, and it'll show you the intake and exhaust valve closing, how well it seals, compare it to the other cylinders. And as you get into this, this is a very dynamic, powerful diagnostic tool. They also have noise, vibration, harmonics transducer kit. You can find a source of a vibration or noise in the car. They have immersion, contact, and clamp type temperature probes. The clamp type is what air conditioning guys use to go around an evaporator or condenser tube. Scopes can have attenuators. Attenuator is a device that increases the voltage range of the scope. So a 10-to-1 attenuator would 10 times the voltage. So if you could read 10 volts on without an attenuator, you could read 100 volts with it. Scopes come in basic kits. Here's a Pico basic kit, or you can step up, spend some more money and get a master kit. The UScope comes with basic and master kit also. You remember these, don't you? I do. I had several of them in my tenure. And we looked at the scope pattern, especially on the secondary, and we said, okay, there's the firing line. This is the off period. There's dwell. This is the spark line. And there is the coil and condenser oscillations, and there is the off time. We knew that when we had a high spike, we had a problem in the secondary, usually a wire was off or open or something. And we learned by looking at those patterns and determining what section of the pattern had to do with what part of the car. And there is no difference between that and the knowledge needed for a DSO. The Sun Machine was an analog live scope, Sun, Allen, you name it. The UScope, which we now sell, is a very powerful tool that fits in your pocket. It's amazing what features this thing has. The neat thing about scopes is they all function pretty much the same. It's the buttonology that differs. What skills do you need for operating a scope? Well, you got to be able to get a pattern on the screen that makes some sense. That's the easiest thing. Number one. Number two, you have to determine, is this pattern normal or not? So you need a resource or a file of known good patterns, and we'll show you how to get those. And if it is bad, what part of the car or what condition of the car will cause that pattern to be bad? And the only way to get good at those three is practice, practice, practice. And the best way to start out practicing is to hook a scope up to a car that has nothing wrong with it. You see what a pattern should look like. The way I interpret or I try to teach pattern reading is using John Hancock's signature, and we'll replace it with your signature. So you have a signature that supposedly is yours. What would you look at to determine if it was a forgery or not? You know how you write your name, so what would you look at to see if it was a forgery? You'd look at the little idiosyncrasies or details of that pattern to see if it was a forgery. And that is exactly the way you read a scope pattern today. Up is voltage, across is time. And you can have hours of time shown on the scope if you wish. There are three basic scope settings that everyone must master. One is the voltage. That is the voltmeter scale. That's the range switch. Time. How much time is shown on the screen? And of course, trigger. Trigger is when the pattern appears on the screen. The UScope screen, we think of graph paper. It has 12 horizontal grids and 8 vertical grids. So this is called an 8 by 12 scope. Some scopes are 10 by 10, some are 8 by 10, some are 12 by 12. It just depends on the manufacturer. So you have one horizontal division and one vertical division. So our time is displayed as time per division. Our voltages are displayed as voltage per division, with the exceptions being some scopes give you total voltage and total time per screen, not per division. The Pico is adjustable either way. You can change however way you wish. All scopes have a buffer. A buffer is a constantly recording and erasing section of the pattern that it is recording and displaying for you. Most scopes will show you partial of the buffer. What you don't see is on the left and the right. However, there are controls on a scope that let you move the buffer to the left or right so you can see what may be off the screen that you want to capture. So all scopes have a buffer. The bigger the buffer, the more the scope costs, how much it can record and store. UScope buttonology. If you have a UScope, there are software versions. The older software is on the left, the newer software is on the right, and you see the difference is a POS icon on the bottom menu bar. How do you know which software you have? You have a UScope, hold down on the down arrow button while you turn the scope on. Many folks don't know this. When you do that, this screen will appear and it gives you the serial number of the UScope and the software version. If yours is out of date, you simply call aeswave.com and they will give you a free upgrade to your software. It does not cost you anything. The horizontal menu bar on the UScope has volts per division on the left, and you adjust your arrow up and down to change it. That changes your voltage settings. And you want to change the menu, you would move the left and right button. So right now we have volts per division, and you notice that the zero line is on the bottom, and I've raised the bottom zero line up. Why do I want to do that? Because I want to see if any voltage goes below zero. So now if I have an 8 grid scope, I see that I am on 1 volt per division, so I would have 8 volt max, but you notice on the upper right hand corner it says 7 volts because I have 1 volt below zero. Voltage per adjustment or voltage per division on 2 volts, I have a very simple digital square wave signal here, and we look at the division, we'll see that we have about 5 volts. And I'm on a 14 volt scale because 2 times 7 is 14. Now, if I go to a lower voltage setting, now I'm on 1 volt, and you see that I have exactly the same signal. However, it's taller on the screen and gives me more detail for analysis. So normally you want as tall a pattern as you can without going off the screen, so you get the best detail. Time is the same way. You can change the time settings by your up and down arrows. Here we have a square wave signal at 5.01 hertz. It's on 100 milliseconds. So we have a 12 grid scope, 100 milliseconds, 100 times 12 means that we are displaying 1.2 seconds. If we change that to 1 second, you notice what happens to the pattern. It's meaningless, doesn't tell us much, but 1 second times 12 is 12 seconds. So if you see a pattern like that and you can't understand why, you need to change your time per division setting. This is the same signal of a scope on different time per division settings. Trigger. Trigger is when the scope starts displaying your pattern. There are 4 basic kinds of scopes, or triggers, I'm sorry, and the hold is the feature of locking whatever you're seeing down. So auto trigger, no matter what you've done to your scope, it will display a pattern. It stacks them on top of each other and it'll display a pattern no matter what. It may not be synced, but it'll display a pattern. Normal, you must, the signal that you're measuring must cross a certain threshold that you have set. It's called the trigger level or voltage point. Single displays a single shot and holds it. Hold on the UScope, and the Pico has the same feature. You can lock it down and then examine in detail the pattern that you got from the car. Trigger slope. Trigger slope is the pattern will display as soon as the voltage goes up, which is called a positive slope. Sometimes scopes use an arrow for that, or it can be a negative or voltage falling slope, and the arrow goes down for that. Now there's tests that you want to use both of those, and Al can talk more in detail about that. This is an unsynced pattern. So if you hook up a scope to a car and you get this, you've not synced the pattern because your trigger level is off. So here's the same recording that I did on a UScope. The trigger level is set too high. Notice it's above the pattern. That horizontal yellow line is a trigger level. So now I'm going to run a video that's embedded into the PowerPoint, and you'll see that I'm going to manually change the trigger level, and it's going to drop. And as soon as it hits the pattern, that pattern will sync, and now it'll be able to be viewed with the pattern. There it is. It's synced. It's still live, but it's synced, and my trigger level is 4.16 volts. Now I'm going to raise it back up again, and it becomes unsynced. In normal mode, trigger mode, your screen may be blank. Why? Because the signal that you've connected the scope to has not crossed what you've adjusted the trigger level to. It needs to see that before it'll display that signal. Cursors. Most scopes today have cursors. Cursors allow you to do very accurate measurements of both time and voltage. And especially with injector testing or pulse width circuits, trigger and fuel pump current ramping, cursors are crucial. You have time cursors, which are vertical, and you have voltage cursors, which are horizontal. Now the cursor, you notice at the top of the screen, it says delta T 13.3 milliseconds. So between the left and the right vertical cursors, there is 13.3 milliseconds that have happened. On the voltage, which are horizontal, you have 3.84 volts between the bottom and the top cursor. Cursors are a crucial part of scope use. So there's 3 essential things you need to know: voltage per division, time per division, and trigger. Questions? We're going to move on. Signal sources, where do we get them? Well, anything that has voltage in it can be used for a scope signal. This is Al's favorite trainer, the EM330-1. It's a running car without the noise and the heat. So we get all, and we can adjust the sensors here. We can adjust ECT, MAP, IAT, and oxygen, and the car will respond accordingly, set DTCs and so on. Plus, we have our ECM or PCM breakout box. All the signals are available. You don't have to go to the connectors to punch wires. The Ohms Law trainer, which I'm going to be using today, has variable DC signals, motor waveform, adjustable pulse width modulation, and a relay kick. The speed and position trainer has the 4 of the most common sensors used today. This is my 4-channel Pico hooked up to that trainer, and you see it has all 4 of those, including magnetoresistive sensors. It's a great teaching tool. Constelab engine benches. About 95% of all the signals on a car can be obtained from an engine bench. Of course, we have benchtop units for ignition and the whole half a car if you want. Scope learning resources. If you haven't heard about Google or Pico Automotive 6 software, you need to do that. So you Google it, and this is what you're going to get. You download that, and I'm going to switch screens here to go to my Pico. The Pico is not connected to the scope. You can download the software, not even own a Pico scope, and have this. And the first box that pops up is no suitable device found. Do you want to run it in demo mode? And yes, I do. So there's my demo mode. The first thing that pops up is the live fuel injector pattern. This can be manipulated with your trigger, time, voltage, whatever. It's a pretty awesome teaching tool. It's not a real injector pattern, it's created. But what I want to point out is up here at the top. I want you to go to automotive, choose a sensor that you want your students to learn about. I'm going to choose crankshaft, and now I have inductive or Hall effect. I'm going to choose inductive. And then do I want to see running, cranking, or floating? I'm going to say running. And the first thing it does is give you a sample waveform of what a good crankshaft position sensor looks like. We'll go back, there's the pattern. And then here's a tutorial on an inductive 2-wire crankshaft sensor. Shows you the pattern, shows you where to hook it up to the scope. Waveform libraries from actual cars. More details about the sensor itself and how it works. Diagnostic trouble codes set by the sensor. It's an awesome teaching tool. I want to show you quickly here, fuel injector. This will show you a 2-channel pattern of a fuel injector showing both current and voltage. There's your opening hump, and there's your closing hump. It's a great teaching tool for students. There's so much more I could show you, but again, we're out of time here, so we got to move. You get how to perform the test with a scope, what scope settings to use, where to hook up the scope lead, sample of good and bad patterns, DTCs, and lots more information. Here are some great resources to learn about scopes. These are Facebook forums that I belong to, and they're all great for teaching. If you want to know about some scope questions or have a known good pattern, there's where you go. This will be on the PowerPoint. Scanner Danner right now is offering free access to his premium channels. If you're not getting into that, you really should. Doesn't cost you anything. It's a great scope learning resource. And of course, if you're a corporate level IETN, there's a waveform library in there with thousands of scope patterns in it. An example of what's on the big PowerPoint that you're going to get, I take each of the major actuators and sensors, I give you sample patterns for it, and where to hook up your scope and everything. It's pretty awesome. And now I want to switch quickly, before we run out of time here, to the UScope. This is the UScope that I've set up, and I want to show you what a feature that most people don't know about. The UScope has a set of stored patterns in it, and I'm going to choose fuel injector, and I'm going to push and hold the button, and there's my fuel injector pattern. And even though it's stored, I can manipulate my menu buttons and change the time and the voltage and so on to make a difference on that pattern. Now, the neat thing about UScope presets is you can store that and have your live pattern superimposed on that. That's why it's a different color. So you won't see the green pattern. You'll see a purple and a green for live. I just wanted to point out that that has a huge storage capacity of different preset patterns that that thing has. It's a great tool. I know we're short on time here, but let me try to get my Pico running up here and we'll show you what's going on with that. If we're running a little bit over, I guess you'll have to forgive me. We want to get rid of that. Okay, Pico. Here's the Pico. Gotta close that out and start up. Now you see the UScope. I have set the UScope up to the Ohms Law trainer, and this is the pulse width modulated signal. That's the generator that we have. I'm going to turn the Pico on, and we're going to see both signals on two different scopes. There we go. I didn't have my plug in all the way. Sorry. Okay, here's our signal. I got to make a, yes.
Dick, there's a good comment here I think you ought to maybe, look at. It says, someone give him more time. So take your time, buddy.
Well, we're always rushed in these things. Okay, going to change my pattern here just a little bit. Now we need a trigger because it's unsynced. We're going to put it right about there. Now I'm going to minimize this. And you can see the signals on both scopes. Now, if I change the pulse width of the pulse width generator, you see how it affects. And this is a great teaching tool also. Talks about duty cycle, frequency, whatever you want to do. So the Pico is a powerful tool. It's expensive. Do you need a Pico to teach? No, you don't. You can get by just fine with the UScope and the signal distribution harness that we have available for you, where I've had 38 UScopes hooked up to that harness. I generate a signal, all 38 of them display that signal. How did I do this today? Here's what I did. Close up, this is the Ohms Law trainer. There's my Pico. This is the UScope, and you see I've got it duct taped down to a block of wood. And this thing on the top is an iPivo document camera. And you saw that it gives us a pretty good image of the Pico, or the UScope. It's not bad. So if you don't need a lot of money to get into that situation. I'm just about out of time here. I'll stop the session and take some questions if anybody has any. I know I blew through this fast, but I wanted to finish up to this point today.
So, Dick, one of the questions is Al Plater wants to know, have you found a way to broadcast a UScope signal?
The only way you can is the way that I've done it. I've talked to George about that, and the physical restraints of the box, the size of the scope, is preventing him from putting the video stuff in there that you need to do. Now you can do like I'd recorded videos with the UScope, but you cannot display live what the UScope is showing. I wish you could, but you can't. Now the Pico, of course, you can, but you can store 2,000 or 3,000 screenshots on the SD card that comes with the UScope. The key to doing that is name them when you record them, because if you don't, they're all recorded by a number and you can't understand what it was that you recorded. So yes, I have probably 2,000 screenshots of UScope patterns, but no, you cannot display live readings without the document camera that I used.
And Al will be showing how to store some of those, right, tomorrow?
Well, here's the deal. This is more a class that we had in the limited amount of time of how to use the scope to teach students about circuit behavior and enhance student learning. If someone wants dedicated training on a Pico or a UScope, we would be happy to do that at a later time. Just let us know in the chat. I would be happy to talk. I mean, we haven't even touched the capacities of a UScope or especially a Pico, but we can certainly do product specific training on that if that's something that is needed. Anybody else?
I'm gonna stop the recording. That doesn't mean we stop the questions or the discussions.
Okay.